Hello and welcome to Restrictions on Composite Functions. To kind of get a feel how these restrictions work, I've got a real mess of a function sitting here. It looks like it's got everything and the kitchen sink thrown in. There's a radical here, there's a rational expression, then there's just a number, and then there's x squared. How do you determine the restrictions? It's actually really easy because you just kind of go through it and look at all the components. For example, is there any problem with x squared with x being any number? No, there's no restrictions with this guy. 101 is fine. What about this 1 over x? Well, we do have a restriction there. X cannot be allowed to equal 0 because that would be the zero denominator problem. So there's one issue coming up from that. And what about the radical? Well, in a radical, we always need the stuff that's under the square root, the x plus 5, has to be greater than or equal to 0. So in other words, I'll bring the 5 over, it'll look a little bit better. X has to be greater than or equal to negative 5. So here we have our two restrictions. X is any number that works that's greater than or equal to negative 5, but not 0. Okay? So that's when a function is given to you. That's how you analyze all of the restrictions. Let's do a fresh new example. And in this example, I have two functions, f of x, which is 1 over x minus 3. And then I have another function, g of x, which is x squared minus 2x. And we're going to make a composite function, f of g of x. And we're going to look really more at the restrictions once we're finished. So what are we doing here? Well, we're taking function f, and the input is g of x. So this is now going to be the input. All right, into function f. Okay, I think that's easy enough. What do we do with our input in function f? We put our input here. So we're just going to go 1 over, and then here comes the input, x squared minus 2x. And then I have minus 3 still. Okay, so that's basically my function. Now there is one thing that I can do. I see that the bottom has a chance of factoring. So maybe that will help us make an analysis. So let's get set up here with x times x. We would need two numbers that make negative 3 that add up to negative 2. So I think negative 3 and positive 1. So now I look at my composite function here, all nicely factored, and it's really easy to see my restrictions. X is not allowed to equal 3 or negative 1. And it's interesting because you can see 3, yes, was a problem in the original function f. But the negative 1 was never a problem for anybody, but it is in the composite function. So you really do have to go through and figure out what your composite function looks like in order to get the correct restrictions. Okay, my last example, so I'm going to clear the screen. Two different functions here. And this time I think I'm going to go after the domain and range. When you find your domain, it's kind of like you're doing the restriction stuff as well. So it's kind of the same kind of animal here. Okay, these are big complicated functions here that we're going to be working with. So I'm going to make an educated guess as to the range. Sometimes that's the tricky part. In this one, I'm going to try to figure out g of f of x and look at its restrictions. So let's see what we can do. First of all, function g, yeah, we're going to plug f of x into it. So f of x is this. This is our input into function g. So what does that mean we're going to do? Well, according to function g, you're going to go and square your input and then times it by 7. So let's do that. So there's my input. and I got to square it. Okay, so that actually looks pretty good. Then I have minus 2 times my input. Okay, so there's where that goes. And then I have plus 1. All right, I can do a little bit of simplifying here, which would be awesome. Really nice is the fact that when you square root and you square, they undo each other. So they just kind of cancel each other out of the picture. And then this guy here, well, there's not much I can do there. I just got to leave it alone the way it is. And then I got plus 1. So one more thing I can do, I got distribute the 7 in. So I have 7 times x. And then I'm going to have 7 times 3, which is 21, plus that 1. And usually we write constants at the end. So I have plus 22. And then I'm going to write the radical in the middle. So there's my my composite function. Now I've got to analyze any restrictions in order to get the correct domain. Okay, so what works, what doesn't work? Anything goes for the 7x, and anything goes for the 22. It's this that's causing any sort of restrictions on numbers we can use. The x plus 3 has to be greater than or equal to 0, which means x has to be greater than or equal to negative 3. So getting the domain wasn't too bad. But the question is, how do we get the range? Okay. Well, the easy way, to be honest, would be if you just threw this into a graphic calculator and you looked at the picture. That being said, that would be very nice, but say we're not allowed or we don't have a graphing calculator. So only one thing left to do. We kind of manually do what the machine does for us. We plug in a few points and we try to pick them wisely and we figure out what the corresponding y values are. So since our domain starts with negative 3, we better start with negative 3 and see where we're at. And then maybe we'll throw in some other numbers, most of which I think guided by which ones work easiest under the square root symbol. So I would use negative 2 because that'll give you a positive 1, and that's easy to square root. Another good one to square root is if I put a 1. A 1 plus 3 makes 4, and that would work quite well. All right, let's see what kind of y values we get. So if we plug in negative 3, we're going to get negative 21 minus then 2 times the square root of 0, and then plus 22. So we would end up with negative 21 and 22, so that looks like 1. So I have the feeling it's going to start at 1. Let's try negative 2 now. So this would be negative 14. Then we'd have minus 2 times the square root of 1, and then we'd have plus 22. So what do we get in there? This is negative 14 minus 2 plus 22. So that's looking like positive 6. Looks like it's increasing, but let's confirm that by plugging in the 1. That would be 7 minus 2 times the square root of 4 plus 22. So we're going to get, looks like 29 minus 4, looking like 25. So without using a lot more points or graphing technology, here is my educated guess. The y's seem to be greater than or equal to 1. And I think we find that we are correct with that. So that's where I am going to stop, and we will catch you later.